Hello everyone and welcome to Edureka webinars. So folks, as we progress in today's session, we are going to look into the concept of IAM, that is Identity and Access Management in Google Cloud Platform. So the agenda of today's session is as follows. We'll start by understanding what exactly is this Google Cloud IAM service, how does it actually work, the concepts of IAM, and then we will look into the security enforcement through IAM, and then I'll show you a quick hands-on with the GCP, that is the Google Cloud Platform. So let's get started, and let's start by understanding what exactly is this Google Cloud IAM, that is Identity and the Access Management service that we have got. See, IAM, which is also known as the Identity and Access Management, helps us to grant the granular level access which are specific to Google Cloud resources. And it will help us to prevent the access to other resources. And this will help us to adapt the security principles of least privilege, which states that nobody should have more permission than they actually need. So this unifies the access control for the Google Cloud services into a single system, and it presents a consistent set of operation. That's the overall idea about this Google Cloud IAM. And here with this IAM, let's understand how it actually works. See, with the help of this IAM, you can actually manage the access control by actually defining who has what access for which resource. That means you will define who, that is the identity, and you will control as what access, that is the role, for which resource. For example, compute engine virtual machine instances, or Google Kubernetes engine instances, or Google Kubernetes clusters, or cloud storage buckets. So these are all the various Google Cloud resources. The organizations, folders, and the projects that you use to organize your resources are also the resources as well. Now here in IAM, the permission to access a resource is not granted directly to the end user. Instead, the permissions are actually grouped in the format of a roles, and the roles are actually granted to the authenticated principals. So previously, IAM often referred to principals as members, and some APIs might still refer them. But remember, it is granted to the authenticated principals with the latest version of GCP. And when we have any policy, let's say allow policy is also known as an IAM policy. So it will define and enforce what roles are actually granted to which principal, and each allow policy is attached to a resource. Now, whenever we have got an authenticated principal who attempts to access a resource, the IAM checks the resource allow policy to determine whether the particular action is permitted or not. So this diagram that you see right here, this illustrates the permission management in IAM. So the model for access management, it basically has three main parts. One is a principal. A principal can be a Google account. Okay, it can be a Google account for end users, or it could be a service account for application and the compute workloads. And a Google group, or it can also be the Google Workspace account or the cloud identity domain that can access a resource. And each principal has its own identifier, which is typically an email address that we would have. Okay, and we have got something called as a role. So role that we have got over here, it defines the collection of permissions. So these permissions determine what operations are allowed on a specific resource. Now, when you grant a role to a principal, you are going to grant all the permissions that this role contains. And we have something called as policy. The allow policy is a collection of role bindings which bind one or more principals to the individual roles. Now, when you want to define who principal, that is my principal, has what type of access or a role on a specific resource, you actually create an allow policy and attach it particular resource. Okay. Now, in this diagram, for example, the allow policy binds the principal like the user@example.com to the roles like app engine admin role, that is role/app engine.app-admin. If the role, if the allow policy is attached to a project, the principals, that is this email address, the person who is accessing with the help of this email address, can gain the access, like where they can actually gain the access which are specified roles within that particular project. Okay, this is the core idea about this IAM. Okay, now here when we talk about this IAM, there are some key concepts which are related to the IAM. So let's go through one by one. So we have got the key concepts like the principal. So in IAM, we generally access two principals. Now, these principals can be of various types. They can be Google account type, they can be service account type, they can be Google group account type, they can be Google workspace account, cloud entity domain, or it could be authenticated users, or it could be all users. So when I say Google account, a Google account represents a developer, an administrator, or any other person who interacts with the Google Cloud. So any email address that's actually associated with a Google account can be an identity, including the gmail.com or other domains. So new users can sign up for a Google account by simply going through the Google account sign up page. And we have got the service account. A service account is actually an account for an application or a compute workload instead of an individual end user. Whenever you run a code that is hosted on Google Cloud, the code runs as the account that you specify. You can create as many service accounts as you would require to actually represent the various logical components of the application. Okay, and we have got the Google group. So Google group is a named collection of Google accounts and the service accounts. And every Google group has unique email address, which is associated with the group. And you can find the email address that's associated with the Google group by clicking about on the home page of any Google group that you would have. Okay, so this is about the Google groups. And I would say that these Google groups are a convenient way to apply the access controls to a collection of end users. And you can grant and change the access control for a whole group at once instead of granting or changing the access control one at a time of the users. And you can also, I would say, easily add principals to and remove principals from the Google group instead of updating an allow policy to add or remove the users. Okay. And apart from that, the members can be of Google Workspace account. So a Google Workspace account represents a virtual group of all the Google accounts that it actually contains the Google Workspace accounts. So Google Workspace are associated with the organization's internet domain name like the example.com. And when you create a Google account for a new user, such as username@example.com, that Google account is added to the virtual group for your Google Workspace account. Now, in the same way, just like the Google groups, Google Workspace accounts cannot be used to establish the identity, but they enable the convenient permission management. Here we've got something called as the cloud identity domain. So the cloud identity domain, I would say it's more like a Google Workspace account because it actually represents a virtual group of all the Google accounts in an organization. However, this cloud identity domain, they don't have the access to the Google Workspace application and the features. Okay, that's the core difference between cloud identity domain and the Google Workspace account. And we have got all users. So all authenticated users is a special identifier, and this would actually represent all the service accounts and all the users on the internet who have authenticated with the Google account. And this identifier includes the accounts which are not connected to a Google Workspace account or which are not connected through the cloud entity domain, such as personal Gmail accounts. So users who are not authenticated, such as anonymous visitors, are not included in this all authenticated users. Okay. Now we also have something called as all users. The value all users is a special identifier which actually represents anyone who is on the internet, including the authenticated and the unauthenticated users. Okay, so these are all about the users. Now coming to the access management, we've got few more concepts. So let's say that I've got an authenticated principal, and this authenticated principal is currently trying to access an individual resource, let's say a compute resource. Now at that time, the identity and access management service checks the resource allow policy in order to determine whether the action is allowed or not. Okay, and here we have something called as a resource. Now, if a user needs to access to a specific Google Cloud resource, you can actually grant the user a role for that specific resource. So the examples are projects, compute engine instances, and the cloud storage buckets. And some services support granting the IAM permissions at a granularity finer than the project level. For example, you can say that you have to grant the storage admin role to a user for a particular cloud storage bucket, or you can grant the compute instance admin role to a user for a specific compute engine instance instead of the entire compute service. In other cases, you can actually grant the IAM permission at the project level. The permissions are then inherited by all the resources which are within that project. An example can be to grant access to all the cloud storage buckets in a specific project, then you would actually grant the access to the project instead of going through each and every cloud storage bucket that you have created. Or in order to grant the access to all the compute engine instances in a project, you would grant the access to the project rather than each individual instances that you would work. Okay, so this is about the resource. The next concept that we have got is actually the permission. So the permissions determine what operations are actually allowed on a resource. In the IAM world, the permissions are represented in the format of service.resource.verb. For example, pubsub.subscriptions.consume. So here, the permissions often correspond to one-to-one with REST API methods. That is, each cloud service has an associated set of permission for each REST API method, which it actually exposes. So whenever we are calling that method, so it needs those permission to call that method. For example, if you use pubsub, then you need to call the topics publish method. You must have the publish.topics.publish permission for that specific topic. Now you don't permissions, like you don't actually grant the permissions to the users directly. Instead, you identify the roles which contain an appropriate permission and then grant those roles to the user. Okay, so this brings us to the next concept, that is actually my role. So when I say role is actually the collection of permissions, and here you cannot actually grant a permission to a user directly. So what you will do is you will grant them a role, as I mentioned, and when you grant a role to a user, you grant them all the permissions that the role contains. Okay, now when we talk about roles, there are various kinds of roles in IAM. We have got the basic role, we have got the predefined role, we have got the custom role. Now here in this example, okay, we've got a role called compute.instanceAdmin, and this compute.instanceAdmin role has the following permissions, like the compute instance delete, compute instance get, compute instance list, compute instance set machine type, compute instance start, compute instances stop. So these are the various permissions that are associated with the role of this compute instance admin. Now here, as I mentioned, there are various kinds of role. Basic role. If I talk about the basic role, roles historically available in the Google Cloud Console. So these roles are, I would say, owner, editor, and the viewer. And we also have the predefined role. So predefined role are nothing but the roles which give fine-grained access control than the basic roles. For example, the predefined role of pub sub publisher provides the access to only publish messages to a pub sub topic. Okay, we can also have a custom role which we can create it to tailor the permission to the needs of your own organization when the predefined set of roles is not suitable. Okay, so this is about the role. And we also have something called as a IAM policy or an allow policy. Okay, so here when we talk about this IAM policy, okay, so here IAM actually provides a set of methods which we can use it to create and manage the allow policies on the Google Cloud resources. And these methods are exposed by the services which support the IAM. For example, the IAM methods are actually exposed by the resource manager, PubSub, and the Cloud Life Sciences APIs, just to give you some examples. Here, some of the IAM methods are set IAM policy, which sets the allow policies on your resources. We've got get IAM policy, which gets an allow policy that was previously set. And we have got test IAM permission, which will test whether the caller has the specified permissions for a resource or not. Okay, so this is about my IAM policy. And this is the overall idea about this policy. Okay, so this actually describes the resource hierarchy. Now, when we talk about this resource hierarchy, the Google Cloud resources are organized in a hierarchical manner. Now, on top, we have something called as the organization. So I can say that this organization is the root node in the hierarchy. Okay, now under the organization, we have the folder. Now the folders are the children of the organization. And then we have the projects. Projects are children of organization or of a folder. And we have the resources. And now resources for each service are the descendants of the project. Okay, and always remember when we talk about any resource, each resource has exactly one parent. Okay, it has actually one parent only. So this is the overall idea about the resource hierarchy that we have got. Now here, while working, you can set an allow policy at any level in the resource hierarchy, and the organization level it can be, or it can be at the project level or the resource level. Now the resources inherit the allow policies of all of their respective parent resources. The effective allow policy for a resource is the union of the allow policy set on the resource level as well as the allow policies which are inherited from the higher up in the hierarchy. So this policy inheritance is transitive. In other words, the resources inherit allow policies from the project, which inherit allow policies from the folder, which inherit allow policies from the organization, and therefore the organization level allow policies also apply at the resource level as well. I hope you are now getting the clear picture as how the role and the policy IAM is actually in a hierarchical manner. To give you an example, here, let's say if I've got a topic A, okay, let me just show you with the help of an example. Okay, yeah, let's consider this example. Okay, let's say I have got topic A. This is the topic A that I have got, and this topic A is a pub sub resource. Now this PubSub resource lives under the project of example prod. And then here, if you grant the editor role to, let's say, micah@example.com. Okay, I'm just giving you an example for the project of example prod. Okay, and if you grant the publisher role to another user, let's say, okay, let's say another user number 2 @example.com, then for topic A, you effectively grant the editor role for topic A to the first user and the publisher role to the user number 2. Okay, that's how it actually works. Now the allow policies for the child resources inherit from the allow policies from their parent resources. So if you grant the editor role to a user of a project and grant the viewer role to the same user for the child resource, then the user still has the editor role which have been granted for the child resource. And if you change the resource hierarchy, then the policy inheritance changes as well. Okay, so that's the overall idea about this resource hierarchy. And while working with IAM, okay, so here, like this with, okay, there are some key security enforcement that we can actually do it with the help of this IAM. So some of the key things that have been suggested are, let me just take you through one by one. Give me a second, team. So there are a few questions. Let me answer those. Okay. So some of the security enforcement that you can do with the help of this IAM is you can actually enforce the multi-factor authentication. So with this multi-factor authentication, you would ensure that you will not only you'll have a password, but also you have another level of authentication, which ensures your account is secure. And set up the strong password policy for the users. And now by using this, you are going to reduce the chances of getting the account get hacked and give necessary but only the least possible privilege. Okay, that is what is said, like least privilege, that is ensure that you provide the access only to the services which are required for the user to perform. And also check and rotate the service account keys and set up the codes as well to get the clear picture as what is happening in your account. Okay, so this was about the core idea about this Google Cloud services. And now with this basic idea, let's go ahead and work with a service that's called as compute engine that we have got in Google Cloud Platform. Okay, now in the hands-on session, what we will do is we are going to create a virtual machine instance for the Google Cloud Platform. Okay, so that means we'll make use of the compute engine VM instance. And while creation, we'll make use of the Ubuntu operating system. Okay, so let's get started, team. So what I'll do is I'll start by logging into my Google Cloud Platform. Give me a second. I'll just set up the account. Okay, I'm now logged into my 𝐵𝐶Labs account. Okay, I'm now logged into my Google Cloud account. Okay, so once I've logged into my Google Cloud account, we'll just get started, folks. Okay, so here, first thing that I'm going to do is I'll start by launching a virtual machine instance. So in order to launch a virtual machine instance, under the navigation menu, I'll select compute engine. Okay, and under this compute engine, I'll select this virtual machine instances, or I can just directly click on this compute engine, and from this screen, I can click on create instance. Okay, so this will take me to a new screen. Okay, so let's wait for the screen to load. Okay, so first thing that it would ask me is enter the instance name. I'm going to say instance 1. That's the default name. You can also change the default name as per your own preference. For example, you say compute instance 1. Okay, so this is the instance name that I'm going to specify, and I'll specify the region as US Central 1, and I'll keep the zone as US Central 1A. Okay, now under the machine configuration, we can choose any machine configuration. Now I'll select the family as general purpose, and for the series, maybe I'll pick up the first generation one, that is N1, for the example purpose. Okay, now once that is done, so ensure that you select the machine type. For the demonstration purpose, I'll select as N1 standard one, which is 1V CPU with 3.75 GB memory. Okay, now we can also go ahead and modify any settings. Okay, so we can go ahead and modify any settings, and we have the boot disk. For the boot disk, let's do one thing. Let's go ahead and select the operating system as Ubuntu. So I'll make use of Ubuntu operating system. Okay, and for the version, so I'll keep the 18.04 LTS, and then we can select the boot disk type. For this example purpose, I'll say standard persistent disk, and I'll keep the size as 10 GB. Okay, and I'll click on select. Now I'll come down, and under the service accounts, so we can select the service account. Okay, service accounts is nothing but the applications running or the virtual machine use the service account to call the various Google Cloud APIs. Now for this demonstration purpose, I'm going to say no service account. Okay, now I'll keep the remaining settings as it is, and I'll click on the create button. Okay, so let's wait for the compute instance to come up. And once the compute instance is up, we'll perform the SSH into this instance, and then we are going to run some basic commands. Okay, I'll click on SSH. So this will perform the SSH into the virtual machine that we have just created. Okay, let's wait. I think the system is not completely up. We'll have to wait for few minutes once the system is booted. Let's wait. Okay, it's not up yet, I believe. So let's wait, folks. Okay, so we have the we have done the SSH into this instance. Okay, so what I'll do is I would start by running some basic command. I'll say sudo. Since it's an Ubuntu, I'll say apt get update. So this is going to update the packages. Okay, once this is done, I can go ahead and maybe I'm going to install some configuration. So this time I'll say sudo apt get install xrdp. Okay, so this is going to install the RDP configuration. I'll press Y and press the enter key. Okay, now once this is done, we'll also go ahead and we'll install the GUI mode as well. Now, the next thing that I'm going to do is I'm going to install the GUI mode. So this is going to install. Okay, now once this is done, I'll just go ahead and perform the restart of my XRDP. Then apart from that, I'll go ahead and I'll switch to my root user, sudo -s. Okay, and I'm going to mention as password. Okay, now it is asking me to enter the Unix password. So I'm going to specify the Unix password as per my preference. Okay, so once I've done the updation, next, what I'm going to do is we can now go ahead and perform the RDP to this instance. So in order to perform the RDP to my instance, so what I'm going to do is I'll just go ahead and launch my Microsoft Remote Desktop. Okay, since I'm using the Mac OS, so I'm going to launch this Microsoft Remote Desktop. And from this screen, I'll click on Add PC. And here, whatever the external IP address that we have, okay, let me try to get that information. So whatever the external IP address that we have got, I can copy this external IP address. And I can mention it right here. Okay. Now, once I mention my external IP address, I'll click on add. And then I'll just double click to connect. Okay. Now it is asking me the username. I'll mention it as root and I'll mention the password. So this will connect to my remote PC. See what it says is, welcome to the first start of the panel. Okay, I'll just say use default config. See, what I'm able to do is I'm able to connect to a Ubuntu operating system, which I am actually hosting on a Google Cloud virtual machine. And I'm able to install the GUI over here. And then I'm able to perform the remote desktop connection for this Ubuntu operating system that is running on my Google Cloud platform. Okay, so this is the clear, I would say, demonstration as how we can perform the RDP, that is remote desktop connection to our system. Okay, all righty. So yeah, this is the file system manager. Okay, so what I'll do is I'll just close the same. So I'll just close this remote desktop connection as well. Okay, so I'll come back. I'm going to delete this instance as well to avoid the billing. Okay, team. So with this, we come to the end of this video. So as part of a learning journey in this session, so we have actually learned in depth and had a in-depth understanding about IAM service. And we have also looked into the hands-on demonstration as how to work with Google Cloud Platform. And also I gave you a demo on how to launch a virtual machine inside this Google Cloud Platform. So thanks again, everyone, for joining in.